everyone. I'm so happy being here. You should be able to see my screen. My name is Sandra Algrim and I'm here with Mark Heckler. We are both cloud advocates working for Java developers at Microsoft, and you should find and follow us on Twitter. Mark, do you want to say anything for yourself as well?
No, that pretty much covers it. You notice we didn't include an email address. I hear email may be a big thing someday, but at least now the best way to reach us is on Twitter. So if you have questions or comments or feedback, by all means, reach out to us there. If you follow us already, that's great. If not, why? Why not? But our direct messages are open. So if you have questions, comments, or feedback you want to leave, but you don't want to necessarily share them with the whole planet, that's fine. Just send us a DM.
So we're going to talk about supercharging your Spring Boot apps. And before we're getting into more details, let's name it why we have to talk about this. So going towards cloud native architectures, we can surely benefit from microservice architectures. So we do have the high ability, like all clouds are providing for us. So we don't need to be only in our data center in our region, but globally spread and worldwide accessible. And we can scale that. I mean, that's one of the main things. We can not only scale up, we can also scale horizontally. And not to forget the velocity. So I think that's one of the main things why microservices are still very famous in our industry. So having a monolithic applications, you all know that the start is probably easy because you don't have to deal with distributed systems that much. I mean, you probably have some dependencies for databases, but not many. So the starting point is very quick and easy. The first features will be out very fast, but then when the system is growing, the next features will become slower and slower. And at a certain time, it will take years for a new feature even, or at least months. And we can't have that. In our industry, the world is changing so quickly. We need to have a certain velocity. Features can't slow us down that much. So that's why microservices are becoming more and more popular, or still are very popular. So one of the things you have to keep in mind if you're using more than just one service to show your product or your business, or to have your business use case covered, you need to have service discovery in place. Like the first service is calling the other one, and they need to be aware where's whom, right? So you need to have the IP address and the port number, but that's certainly not what we want to put in our applications. We want to have something very namingful, meaningful, that we don't need to deal with IP addresses and port numbers. Trust me, you don't want to do it by hand. I've been there. Was at the beginning not too bad, but then it's also not scaling. So I mean, we had like IP ranges for this, but yeah, still you don't want to do it. You don't want to have a list of your services and manage that by yourself. You want to have it managed for you. So one service is saying, where are you? And the other one is saying over here. And we need to have that automatically. So that's also, and the registration. So your first service will always have to register themselves in the so-called service registry. And then the other one calling this service can just have the meaningful name, and then checks with the service registry where the IP address is and the port number or whatever is needed for them to connect to each other. So we're not talking about URLs here. We're talking about service IDs to the local to locate the services. And I feel that's very handy, and you will definitely need that in your microservice environment, and you don't want to do it by hand, trust me. Another thing we need is when we talk about our release management, we probably have different environments. And Mark, can you go on what you need there for?
Sure, happy to. So as Sandra mentioned, when you get into distributed systems, it solves a lot of problems, right? That's why people do that. That's why we kind of have migrated to them over time, but it also introduces some challenges that weren't there when you had a single, rather large and bulky monolith. Now the monolith, there's always one place to look for everything. The problem is it's tough to find it when it's that huge. The other problems, of course, being scalability and velocity and things that Sandra's already covered. But when you start breaking things out, when you start breaking functionality out into different services, what you find is that you introduce some challenges. So for instance, if you have different environments in which you're deploying, so in this case, like development environments, QA, test, prod, you also have the issues that come with scaling. So if you have when you start breaking out functionality, you typically don't break out a single service, right? Because a small group of services kind of combine forces to provide a capability. And typically those services aren't just one, they aren't one-offs. So you don't have 3 services, for instance, one of each kind of service dealing with each other, because they, again, have to scale. So service A may need to scale out to 10 instances of service A. Service B may need to scale out to 20 or 50 or 100 instances of service B. And once you start getting multiple instances of multiple services, as Sandra already mentioned, you have issues trying to find each other, trying to locate each instance of each service. But you also have the issue that when things change, when the environment changes, you would ordinarily have to touch each and every one of these instances of a service that's affected. And of course, that leads to downstream changes that you need to touch each and every one of those. And it gets to be a quite massive ripple effect. So externalizing your configuration gives you a lot of control over that and brings sanity back into the conversation. Because when a particular kind of service, a particular instance of a service, needs to pull its configuration, it can either do that internally, which again takes us back to that having to touch each and every one when changes occur, or it can externalize that configuration. And that's where something like a configuration server, a config server for short, comes into being. Because if you can update that in one place, then you can push or pull, depending on your mechanisms in place, you can propagate those changes to each affected instance. This gives you additional flexibility because, as it says in, I think, the 3rd bullet point here, it allows you to do 0 downtime deployments. You can do A/B testing, blue-green deployments, backward compatibility, so you can do upgrades while still maintaining needed functionality under the, quote, old system. So it gives you a lot of flexibility and, again, brings sanity back into configuration changes for microservices, for instances of a particular kind of microservice. Next slide, please. Mm-hmm. And there are many ways to accomplish this, right? But the simplest abstraction is kind of in the idea of anytime there's an externalized configuration, or even internalized for that matter, these are properties. So properties are what? Typically a key value pair. For this thing, we need to go and grab this value. So if we want to point to a database, here's the location for the database. Here are credentials. Here are different service APIs that we're going to be interacting with externally. And of course, we need to, when we start looking at externalizing that configuration, these are basically text values. And we need to have some mechanism for auditing them and version controlling them, and again, updating them and pushing or pulling changes for them. And we take care of all of these things normally with our code, right? And what do we use? Well, we use Git in most cases. So there, again, many mechanisms you can do, Vault and things like that. But at the simplest abstraction, this is typically just a matter of handling a Git repository. So you can use local or remote Git repositories, typically some combination of each. When you're talking about your various different environments, but it allows you to gain that kind of control, and the config server interacts with those Git repositories to provide those configuration changes to any services that are using that config server.
Okay, and that brings us to the next thing. So saying that we are distributing our business logic across multiple services to be able to keep up speed with our velocity, we also need to be able to troubleshoot, so you also to do distributed tracing. So we really need to be aware what's going on and with our end-to-end transactions. So otherwise, so this service might be calling this one, and then my request is going to be spread across multiple other services. And we really have to monitor all of these to be aware who's talking to whom, how many instances do I have, how long did it take for my request to go from one side to the other one? Why did it take so long? What are my dependencies? Is there something missing? And especially if I have any bugs or performance issues, I want to know which microservice is responsible. So where need I go to find the bug, or where should I start my troubleshooting? So, and you can integrate some distributed tracing with your apps. For instance, there's Zipkin, where you have a nice UI, all the data will be collected and then stored and queried for you, and then displayed in the Zipkin UI. You have this in all of your applications integrated. And for me, the best thing to do is that I don't need to care at all. So I just want to create my application in Spring Boot and then have it deployed, and it should be able to find all the other applications. So doing that, having the config server in place, and I also want to be aware of what's going on. So I also want to have in-place monitoring and everything visible for me very easily out of the box. And that brings us to Azure Spring Cloud. So today, we're first going to introduce Spring application development. So Mark will enlighten us what's actually the difference between Spring Boot and Spring Cloud. Then we're going over to a Spring Cloud overview and say what are the benefits with this joint adventure. We started with Pivotal, now VMware on the Azure cloud. And then we will guide you to some demos, so some live codings I can't wait for, before we're having the next steps for you provided. So Mark, Spring Boot and Spring Cloud. Is Spring Cloud always in the cloud?
Yeah, and this is something that, I mean, we've talked about this at length. This is something that I guess it's a rather unfortunate name in some ways, but there's just no easy way to describe a lot of concepts in a couple or three words. So here we go. That's why we're here. For those of you who are familiar with Spring Boot, that's great. Spring Boot is very well known within the industry, but again, within our industry, it's a rather large industry. So if you haven't worked with Spring Boot before, that's perfectly fine. But as it says, it's designed to get you up and running as quickly as possible with minimal upfront configuration. And why is that important? Well, because most of us over the course of our careers do a lot of the same things over and over and over again. And again, coming from a computer science background, we see patterns, right? And yet, after you see that repeated 6, 8, 20 times, you kind of become numb to it. But you realize when someone shows you something different and says, look, you don't have to go through this same tedium every time you create a new application, every time you work on an application, it's kind of startling, right? Because you realize all of a sudden how much time you've wasted doing the boilerplate dance over and over again. So Spring Boot helps you step out of that and become more immediately productive by taking some of the tedium, the patterns, if you will, that are repeated constantly off your plate. Spring Boot is eminently configurable, but it has something called auto configuration. So in that 80 to 90% of use cases, it picks up those patterns and does them for you by checking your class path, by looking at your annotations in your code and your properties, any beans that you create, and it just kind of creates that environment around you by default. Again, you can tweak it, but you don't have to. And you're more immediately productive to deliver real value to your users and your customers. Spring Cloud extends that. Now, it's not a separate cloud. Spring Cloud you can use locally. You can use it on any public or private cloud. But what Spring Cloud does, as the Spring Cloud project, as it says, provides a set of tools that makes communication between microservices easier. And I always like to point back to even in a monolithic world, even though we think of a monolith as being self-contained, most monoliths have to deal with external systems as well. How much more so when you're talking about a distributed system, a distributed set of applications. So Spring Cloud makes that much easier due to auto configuration and certain built-in opinions. Again, everything's overwritable, but it makes your life so much easier as a developer to actually produce and deliver things. One thing I do want to point out that I frequently forget, Sandra, and you've kind of tapped me on the shoulder with this before, is that our whole idea of supercharging Spring Boot applications is because you can develop an application that can be the best application in the world or the best distributed system of applications in the world. But until you get it to production, until people can use it, until your users and customers can benefit from it, it's pretty weak, and we don't like weak systems, right? So that's what we're here to do, is supercharge those applications and show you how to get them all the way into production, doing useful things for the people who care. So common challenges. This is something that, we've talked about microservices. I think everybody acknowledges that there are certain benefits they bring to the table, but they also realize they can get out of hand rather quickly in terms of manageability. But that's what some of the Spring Cloud components give you. Sandra mentioned and explained the service registry. I mentioned and explained the configuration server. Of course, we have dashboards that kind of cover these things. Distributed tracing, Sandra mentioned, that's very important because when you have a lot of moving parts, this gives you, again, that flexibility and resiliency and capabilities that you need. However, it makes diagnosing and troubleshooting things sometimes a bit challenging, but that distributed tracing, again, draws that power back into your hands. You have things like a circuit breaker dashboard, a configuration server dashboard that gives you visibility into that. You're going to also be interacting with things like databases and message brokers and external APIs. You'll have an API gateway that will control access to your overall architecture, your system, your distributed system. And all of those things are absolutely wonderful. You can see they're Spring Boot-based applications, even among themselves. But of course, that leads to a further explosion in services that you're managing, which makes things, again, it simplifies your life as well as bringing a lot of other external complexity to it, which is why we need some things to maybe go to work for us for a change. Sandra, you want to take this from here? We kind of tag team on this. So do you want me to take it? You want to take this one?
Sure, as you want. So as Mark said, we have our Spring Boot applications here in our user environment. So you can have as many applications as you need for your business logic or for your features to be completed. And then I have, this one is in my user environment. And then as we said, we also need other Spring Cloud services, such as the registry or the config server. But there on top, we have the lifecycle management in place. You know, we do need a blue-green deployment, and we might also want to do canary releases, and why not have that out of the box? We need to have app resiliency, log streaming, data encryption, custom domains, self-diagnostics. And Mark, I mean, we can't go without Kubernetes in those days, can't we?
Well, we probably could, but who would want to, right?
But I don't want to manage it, actually. So,
exactly.
I don't want to create I mean, I'm a container fan and I love to do containers, but in real world, I want to create my application. And as you said, we want to supercharge it. So we need to have it up and running in the cloud or somewhere in production for us to provide the benefits to our customers and end users. So, and for this, we have the Azure Spring Cloud running for us, integrated with Azure Monitoring, Azure Active Directory, all the service bindings we can use with the databases, NoSQL databases, as well as Azure Cache for Redis, for instance. And here's also fully CI/CD already possible, so I can use Jenkins. Azure DevOps is even integrated. We're still waiting for the GitHub Actions integration, but it will come soon out of the. What I feel very cool is that this joint effort we're having with VMware nowadays. So you can have all of this, but you don't need to care for it so much because it's all managed for you by our partnership we're having with Microsoft and VMware. So you can really focus on your Spring applications, on your Spring Boot applications, and don't need to deal with any containerization, Kubernetes, which network you're going to use, how to set up the blue-green deployment, how to add the application insights. Everything will be there provided for you. So we can really see that the Azure Spring Cloud is a fully managed Spring Cloud service jointly built and operated with VMware. So we have the managed infrastructure, the built-in app lifecycle management, and the ease of monitoring. I can't wait to show you. So it's already demo time. Get ready. So here is my Azure portal. I have a Azure Spring Cloud cluster up and running. By the way, if you want to do the exact same thing, -learn, and then there's a full Java learning path. And at the very end, you have the monitoring Java applications on Azure Learning Path, learning module. So learning path is just all about Java on Azure, or most of Java on Azure. We even have more. It's something mostly our team created, so we're very proud of it. And here you can have the self-paced learning experience. And one of this is setting up a simple sample and application environments. And that's what we did here to get this cluster. If I have a look at the applications, you can probably guess what it's taking. So yes, it's taking the Spring, from the Spring example, it's the pet clinic application. And when we have a look how that looks like for our end users, we can just check on the API gateway. So here we have our pet clinic with the cat and the dog, very cute. So Mark, this time we have time for very cute. Check the owners, see even more details, maybe edit the owner. This one is all stored in a MySQL database on my Azure cloud, and also the name of the vegetarians and so on. So talking about monitoring, as I just showed you, so we also can check the settings from the config server, from networking, and so on and so forth. We didn't have to do anything to make that to configure by ourselves, because as Spring Boot is very opinionated, Spring Cloud is as well. So you do have the default settings, which will all work for you, which is great because it's supercharging your app. You have like almost no time from your app creation to the deployment. Mark will do that later on. So for my metrics monitoring, I can have all the common metrics already in place for me. So I can check on the app CPU usage, very handy. I can also change my line chart to an area chart to make it a bit more visible, also for people maybe with vision issues or just because it's pretty. I can also check with more filters. I could also go with a grid. And there are a bunch of metrics I can filter for. Oops. Like I have the app CPU usage, but I can also get the error for my Tomcat. I can check what's going on with my Ingress. So it's using Ingress underneath. As we said, there is Kubernetes running underneath. So we can have all the powers that a Kubernetes cluster has for us, but we don't need to check on it. So we just get the metrics out of it. We don't need to define anything for this to have it happen. I can also get my performance data, so what's happening on my JVM, which can be also very handy, especially if you want to tune a bit for either high throughput or if you need a very fast response times. So you can check what's the maximum memory, probably always same. Also process CPU usage, probably want to filter by maximum to make it even more clear what's happening. Yep, and again, we didn't also get all the information from Tomcat, also from the session Tomcat. And then what I really loved is we didn't have to change anything in our Java code. It was just Spring Boot apps being deployed to Spring Cloud, and we get all of these, which is amazing. Going even further, I can now also benefit from the Azure clouds, and especially from application insights. You probably all are aware of those famous Netflix talks where they were like, okay, our microservices, and introduced their concept of using microservices. And then they admit that at some point they're not aware how many microservices are actually running and who's talking to whom. And that's probably something, I mean, I'm not sure if that felt very cool, but I think it's a bit frightening. So I want to know what's happening in my cluster. And that can actually never happen with your Spring Boot, Spring Cloud clusters, because you have this application map, and I'm a huge fan of it. So here I can see who's talking to whom, how many instances do I have of each of these services. I can also change the layout to make it even more easy visible for me. And then I can also drill a bit into and view the details or filter by this node. You can also see that you get already the request you can use to talk to this particular service. You can investigate in the performance from here already. As you can see here, we also have usually we have the performance numbers as well. Interesting. Anyhow, so I can already see my requests that are available for this particular service, and I can investigate to the performance from here. I can also use the smart detection filter. So if I would click here, it would find me some performance issues or anything else that the Azure Cloud thinks I could change. We have also the live metrics. What I really like, especially if you're doing some load testing in your dev or staging environment, or if something huge, like I think it's almost Black Friday time already. So if something like this is happening, you can also get together and check your live metrics. You can, like normal, search for a transaction, check your availabilities, search for your failures, and as promised, the performance dashboard. So here we do have, by all the operations, we can see how long it takes and how many we are having. And then we can filter by request count or CPU or available memory or the storage. And we can also drill into it. And here we have the samples that we can download, or we show our top 3 dependencies here. You can also check on the common properties over there. And what I also like is that I can not only filter by operations, but also by their dependencies. As no services is on an island, also monolithic applications do need a database at some point. So you can also see how the dependent services are doing and how long it will take me to get from here to there. So here's the SQL metrics, how long it takes to get the requests being handled. And I can also filter by roles. So I need exactly, for instance, here the available memory for my services, and then switch between those ones. So I feel that's amazing. I mean, imagine, I just remember how long it took me to get for my clusters I had to handle by myself, like Kubernetes clusters or even the DCUS clusters I did before in my career, to get this monitoring up and running, or some kind of this monitoring up and running. So that's very, very cool to have that all in place without having to deploy anything specific. And speaking of deployment, why don't we go into live demoing and live coding? Mark, do you want to take over?
Sure, I would love to. And I do want to say that if this is your first time seeing this panel, this portal, it can be a little overwhelming because there's a lot of stuff here, but that's actually 2 things. One, that's what's to love, because it gives you everything you could possibly imagine. And the other is that there's kind of a breadcrumb trail that you can start to follow even from early stages when you first start deploying applications, and start getting some really valuable information very easily, and then expand your knowledge as you go through it. So it's just very approachable, but very powerful. Okay, so let me take over with the screen, if you would.
Yeah, maybe you can steal, because I'm going to, let's zoom and can't find where to stop.
Wahaha, it's telling me I can take it. Do I have it?
Yeah, take it, please.
I have it. Oh, this is nice. Okay. All right. So let me go to here and bring this over. Yeah, so this is, well, this isn't what I wanted, but this will have to do. There we go. Okay, so we've talked a lot about how Azure Spring Cloud gives you the ability to create this environment that supports and enables your microservices and gives you that visibility into how they work, how they're interacting with each other, and to see what's going on within, as well as the portal and how you can use that to see inside the Azure Spring Cloud structures that are working on your behalf. So let's drop something else into the middle of it and see if that picks it up and allows it to interact with them. And of course, we know it will, because live demos always work, right, Sandra? I mean, this is never a question. It always works. Things go flawlessly. Okay, so if it doesn't, we have plenty of people here. We can troubleshoot it together. So I'm going to just create another Spring Boot application, just again to kind of drop in the middle of the lake and see if where the ripples take us. So I'm going to use Java as the language and Maven as my build system. Again, you have choices, but I'm going to go kind of straight down the middle of the road here, and we'll see again where that takes us. Going to use the current version of Spring Boot, which is 2.2.5, current production version. I'm going to change the group to Sandra and Mark.com, because it sounds like that would be an awesome company. We're teammates. We have a great time together, and we're just kind of enjoying this week because we're getting to present together, which is really, really a treat. So I'm going to create an artifact here. We're going to call this, if I can type, an owner API, because we have owners, we have pet owners, we have customers that come into our vet clinics and they bring their beloved pets. And we want to somehow create this application that we can query those owners, maybe to use in a different way, external to the application. Sandra, we didn't even get a chance to show the application yet. We'll circle back to that. Or did we? No, we did. You showed it, right?
I showed it, yeah. But you can go back to that.
No,
And,
I
and
was
show the owner API as well.
I was geeking out on the portal, and I completely forgot you showed that early on. But yeah, so I mean, you have a self-contained application, but we want to expose an API for the owners so we can do something. We can contact them. We can follow up after visits or something like that. So I'm going to use jar packaging because it is, after all, 2021. Why would we use WAR packaging? I don't know. Maybe there's a reason, but we're going to use a jar. We're going to use Java 11. We'll just state it again, kind of in the middle of the road. I'm going to add some dependencies here. So I'm going to bring in the reactive web dependency, which allows us to interact with reactive streams publishers for APIs built around reactive streams publishers or not. It's the most flexible option, so I'm going to choose it. I like flexibility. I'm also going to bring in actuator because if I can type again, that gives you your production ready capabilities, your features within the application that helps you to monitor and manage the app. I'm also going to bring in the discovery client because that allows us to interact with our service registry. And finally, Lombok, because I'm a lazy developer. Lazy good, not lazy bad. I just want to be very clear about that. I think it's silly to redo the same things over and over if you can find a way to make your tools work for you. I don't always use Lombok in production environments, but I really like them for demos because they allow me to cut through some of the clutter. So I'm going to generate the project, and I'm going to drop that right here on my desktop. Pardon me. And we're going to open our project here. And of course, the Spring Initializer gives you one way among many ways to create an application, whether you go through the Spring Initializer or you can go through your IDE or curl or HTTP. It's all good. You have options. So let's see. I'm just going to create a new Finder window because for some reason it did not do that for me. So go figure. So we're going to open that up. My IDE of choice, my daily driver is IntelliJ, but I like VS Code. I like NetBeans. I like Eclipse. I even use Vim from time to time, but please don't use Emacs. You know, whatever you do, please have some self-respect. So anyway, we're going to use IntelliJ today. Apparently, there are Emacs fans in the audience. That's kind of scary. Okay, so here's our owner API. I'm just going to go ahead and open the POM if IntelliJ catches up with me here. I said wonderful things about IntelliJ and then it slows me down here. But here's our POM. This is our project that allow us, our build file that allows us to create our project. And of course it has the dependencies we wanted to include. They're all there. So that's a good start. And I'm going to just go to our application code. If you're not familiar with the Spring Initializer, it generates only the code you see here, which is your main application class main method, but otherwise it just creates your project and we can use that as our starting point. Now I'm going to create our domain class here. We'll call this our owner class. And let's see, so we have things like our owner's first name, right? First name and last name and address, city, and telephone. Let's just go with that. That's simple enough. And once again, I'm using Lombok, so I'm going to have Lombok create my data class. That just with the Lombok annotation at data, it gives us our getters, setters, equals, hash code, and toString methods. And we're going to go with that. And I'm going to just create a simple REST controller here. This will be our owner API controller. And we need some way, right, to interact with our owner service, our other owner service that we have. So I'm going to use a reactive web client to do that. And I'll just use web client.create. And we're going to point to our exposed endpoint, exposed internally for our owners that we have already, our owner service. So we're going to point to http://customer service because we kind of, we break this out. We call it customer service, but it's our owners that we're going to interact with. And as Sandra mentioned, we don't want to key this in. We don't want to hard code IPs. We don't want to go through extra convoluted means to find our services. What we want to do is just say, give us an instance of our customer service. And our service registry will say, why? You have 5 instances of that. Here's one. And it will make that connection for us, which is, again, very, very powerful. So I'm going to create a get mapping. What I like to do, especially for demos, is just create a greeting so we can kind of see this right up front that things are working without any additional complexity. So greetings, JCon. Okay, that looks sufficiently important, right? 4 exclamation points. So that's That's weighty enough. All right. So we're going to do another get mapping. And this is where it really gets important, right? We're going to query our owners. I'm going to get or return a flux of type owner. Now, a flux is one of those reactive streams publishers that I mentioned. If you're used to dealing with blocking types or imperative types, as we sometimes refer to them, not entirely accurately, but we return typically from a method or an API endpoint, a single object of type T, or an iterable of type T. So 1, 0, 1 in one case, or 0 to many in another case. And within the reactive streams parlance, 0 to 1 is a mono. So it's 0 or 1 values, or a flux is a stream of values. And that can be a small number of values, like 5, 10, 20 values, or it can be an unlimited number of values that come in over an indeterminate amount of time. What this gives you is the ability to not necessarily block until you get them all and send them back in one big blob. So that's good. Blob, not an official term, just kind of a technical term. So anyway, so I'm going to get the owners here, and we're going to use our web client to get those. We're going to retrieve them, and then we're going to convert the body coming back to a flux. Again, we're returning a flux of type owner. So a flux of type owner, right? And that's sufficient. I'm also going to, just for fun, whoops, let's go back here and do that right. And we're going to return a single owner. So that way it just gives us a fast and easy way to test this. Again, with a mono, we'll return a mono of type owner. So get one owner and return our client.get, retrieve, and we're still getting back 0 to n values, right? So we want to, we understand we're going to be getting back a flux, but we just want to grab the first one and send it back. And then of course, IntelliJ is giving me some grief here. So it's saying, hey, I can't identify this class, help me. So I did. And that's it. That's a very simple example, but here's where it gets fun, right? So we're going to go to our desktop and go to our owner API. We're going to build this with Maven Clean Package. That gives me a moment to take a sip of excellent coffee here. So we're going to do this build. And then I am going to just come back and deploy this. And then while this is deploying, I'll show you something very quickly. And then what I would really love to do is if Sandra is willing, have her show some of the scaling capabilities. What you see here is a little bit of some errors showing up. These are just because we don't have a service discovery registry running locally. I don't. So it's giving me that. That's perfectly fine and acceptable. In this case, errors are not always a good thing, but in this case, it's irrelevant to our goals. But here I'm going to deploy this using Azure Spring Cloud App Deploy. And we provide the essential information, some JVM options, and it just takes to it and goes. So let me show something really quickly. And then again, if Sandra is willing to indulge us, I'd like to have her come back and show some of the scaling things, because I don't think we got to those just yet. But here are applications. Let me go back a little bit here. Home. Oh, that's just my applications here. So resource groups. And there we go. There we go. So there's my Spring Cloud and then our apps. So for instance, if I want to go to the admin server, and this is a little more, this is a little inside baseball. This gives you kind of the look behind the scenes. It shows you a very simple high level. Again, if you're looking for a way to distill the information, we see that we have a couple of instances of our service registry running. We have one each of these services running. Let's see. So I want to see if I've got this back up. I don't. So let's go ahead and Sandra, if you don't mind showing the scaling, then I'll come back and we'll make sure that our owner API is working fine and I didn't botch something in the coding.
Okay, so I will steal it from you.
Yes, please.
Okay, so here's our application map again, just that we are where we are. And I will go back to my Azure Spring Cloud cluster. So you can scale basically, where is it? So here are my applications. So let's see. Here's my app service. Yeah. And for instance, the admin server, And what I probably might want to scale, it might be the API gateway, for instance, or something which gets more traffic. So for instance, the customer service. And I can scale up and scale out very easily here. So with memory and CPU, I can choose and just change that with 0 downtime, obviously. And I can also scale out. And yes, I can do that manually, but that's not fun at all. I would want to do a custom auto scaling. So based on my metrics, we already had a look what we can choose there. I would then scale automatically for me. And I could even set up a rule so that it won't scale, or that it will then scale. Like, for instance, if the CPU percentage is above 70%, I want to scale up, for instance. And what I like also is that I do have instance limits. So I can set a minimum instance count I want to have. For instance, I always need 2 for whatever reasons, policies, but I also can specify maximum, because at the end of the day, you got to pay for it. So just to be very safe, I could also set a maximum. And there's also a default value. So that would be always the kind of optimized way the Azure cloud would try to get to, or the Azure Spring Cloud would try to get to. And
Sandra,
I really like this. And what I also love is that for your deployment, you can go the way Mark just showed with the Azure CLI, or you can also create a deployment over here. And then, yeah, and what's usually inside, so it's also saying that you can use the extensions and then go with these AZ commands, but you can also go with Azure, how's it called? Azure DevOps, or you go with the plugins for your IDEs. So we have also beautiful plugins for IntelliJ as well as VS Code and Eclipse, where you can just right-click, deploy your app, and also get the URLs for it. But Mark is showing the open way for everything. So you can use everywhere the terminal. So that's cool as well. And with this, I think I want to give back that you can show your application. And we also got a question in the chat.
yes.
I'm not sure if you saw that already. Oh, yeah.
I haven't, but yeah, let's answer that question. Then I have a question for you.
Okay, sure.
Oh, how can you return a finite list? Can you distinguish between finite and infinite? Yes, you can. We don't really have time to get into specifics, but the reactive streams, for instance, you can do a take and a specific number. And that allows you actually to exert something called back pressure, or enforce something called back pressure. Again, I don't want to get too far down this rabbit hole. Very happy to talk about this at length. But what this does give you is the ability for slower clients to not be overwhelmed with a very large volume of data, or a fast producer in this case. So by all means, please catch up with us offline. Happy to discuss this at length, but that's a great question. And yes, of course, you can do that. I do want to ask you, Sandra, coming back to a question for you, because that's particularly powerful how you can scale, but can you scale with multiple conditions to where you can have so like this weekend or every weekend we can scale down, except for Black Friday weekend when we want to scale up or scale out, I should say?
Yeah, we can also scale up and down on timing issues. Like I know that my service is only maybe available in German, and because it's for German customers only. So I don't need to be on heavy load, or I don't need to be prepared to be on heavy load in the nights. So I can just scale very much down during all nights, for instance. So that's possible. And then I can set up my specific roles. And probably if there's something like Black Friday, which is just happening once a year, I can also set that up. And I can also set those roles up and words up using ARM templates or Bicep templates. So I can actually store those ones and using infrastructure as code to define them in an appropriate way. I mean, we have 2021, so that's something we can make use of. Mark, what do you think? Shall I just finish with the slides and then we can go on with the live coding until we don't have any much more time?
Well, let me just jump in and show the API working, and then we'll pop back. It shouldn't take but a moment. So let me do this and share and see it deploy. And in fact, it actually deployed, finished deploying right after I gave you the control, which is usually the way it goes, right? So here, if we go back to our service, we'll go to our owner API. And then, of course, we can go to our endpoint. And we see that we've got our greetings here, our greeting, which is very important that we see, right? So we got JCon greeting. I'm just going to go to the owners and make sure that, oh dear, what did I do wrong? Okay, so let's go up and, okay, so we will go back to you and I'll figure out what I did wrong. So let me stop the share and you can take back the share. That's embarrassing, but that shows it's live. We don't hold anything back ever. So Sandra, take it away and I'll go back and see what I've botched here.
Okay, so you want me to finish the slides while you're fixing it?
Yes, please.
Okay. Time is limited and we are live. So I just found the docs.microsoft.com page for the provisioning Azure Spring Cloud using Terraform page, because we got the question if we have infrastructure as code already or also documented for Terraform. And there it is. You can also use ARM templates, as I said, or Azure CLI or Bicep, which is the much more human readable way of, so it's ARM in the background, but everyone uses now Bicep also inside Microsoft to generate resources. So going to our slides, we have the Spring integration completely with Azure. So that's the power you got if you use Spring Cloud in Azure, named Azure Spring Cloud. So you have everything, all the magic you have from Spring Cloud, the app configuration, the event hubs, the service bus, storage Redis functions, for instance. You also got everything from Spring Data, nicely integrated with the databases. So SQL database, Postgres, MySQL, for instance. You can also integrate nicely with Redis Cache, Service Bus, and the Azure monitoring, which I showed you already. And what I also love is the Spring Security integration, which is using then the Azure Active Directory underneath, or you can also use AAD B2C for it. And yeah, Spring resources as well. So that's very cool. I already said that Azure DevOps pipeline are also built in for Spring Cloud already. GitHub Actions is not, and that brings us to the roadmap. So we already are general available, which is cool. So it's enterprise ready. We have the troubleshooting already in place, what I showed you before. We do have the VS Code extension to build Spring Boot apps, as well as nowadays for IntelliJ and Eclipse. We do have the VNet in public regions, GA, autoscaling is GA. We have the cost control already there. We can troubleshoot. So that's also what I showed you with the, especially for the performance. We do have a third-party APM integration. We do have a YouTube channel where we're showing this integration with, for instance, Dynatrace and so on, or Datadog. And you can have even more logs. What's coming next is this GitHub Action task I can't wait for. And also, with Kubernetes, you can also stop your cluster and reduce costs. For instance, that's important if you're just a developer wanting to try out things. For Azure Spring Cloud, nowadays, you have to delete it. Otherwise, it will cost you money. But very soon, we have this suspend and resume so that you can also keep here low on cost. And yeah, the regions which are already available, and more will come. If your region is not available yet, please reach out to us. Then we can make sure that it will be there soon for your company. You can learn more. We will give the slides later on already at this learning path I showed you. And there's also a module just around Azure Spring Cloud. We also have a full self-paced GitHub Spring Cloud training you can do. And you're also very happy, or you can use here the JCon feedback, or you can also give us feedback on Azure Spring Cloud if you want to make sure that the product teams will be aware of your feedback at aka.ms/springazure. And with that, Mark, are you already ready to get back on track?
Yes, let me take the screen. It was a simple typo. I literally left out a single letter for
I'm
the
so sorry
endpoint.
I didn't saw it. I
Oh,
should
me
have
too.
catched
Yeah,
it.
Well, we both missed it. I think these things
Where's the
happen.
whole
So
pair programming for? Exactly, if we have like 102, 101 participants. Come on, someone should have seen.
so we're up and working. It was again a very simple fix. I just fixed it and pushed it, and everything is happy. So yeah, so we've got everything working as intended, as we knew we would, right? Because again, things never go wrong. At least never go wrong long term in demos, on live demos. So. But with that, I will turn it back to Sandra and just if you could restore the last slide in case people didn't get it. Okay. Thanks for coming. As you can see, we love Spring. We love helping developers get to production in the cloud and really supercharge their applications and make them count, right? Because until people can access them and use the functionality, they're just experiments. And we don't like that. We like the real deal. We like it to actually matter. So thanks for coming, and hope to see you around afterward.
Thanks very much.
Oh, and I did see that someone asked a question about Terraform, and somebody responded, absolutely, Terraform and Pulumi. I know we have some Terraform resources. We're adding to them all the time. Pulumi, I'm not sure. We'd have to, Sandra, do you know? Or
yeah, we are partnering with them. So okay. I hope it will be available soon. And as we just saw that there's actually a session from Rory, our other colleague, who's doing a whole Terraform session for Spring on Azure. And I think it already happened today or yesterday, but the recordings will be all available very soon on the JCon YouTube channel.